The last video was ended a little bit abruptly, and I meant to do that because that in a nutshell is where the solar system came from. The solar system came from a bunch of dust. That's it. And of course, the solar system includes everything that's in it. You, me, the trees, the oceans, the planets, the sun, everything just came from intergalactic dust that was sitting around not doing anything. All right. There's going to be a little bit more to it than that I'm going to get into now. But I did want to comment just a little bit on this statement here about the dust, this original intergalactic dust here, being 75% hydrogen and 25% helium. Turns out these elements are very common in the galaxy and indeed maybe the universe for the following reason. If you look at the periodic table here, of course hydrogen is right here and helium is right here. These are the simplest atoms, period. In other words, all hydrogen is then, as you may remember from your chemistry class, is a single proton and a single electron. It's just going around like that. That's it. So in other words, a very unsophisticated so-called atom. And if there's any very extreme circumstances like heat or that sort of thing, then this electron, as we know, sort of in the center of the sun is going to fly right off, and you may just be left with a single proton. Maybe you'd write it like that. So very simple, nothing sophisticated at all. And the same sort of goes with helium over here. Helium is a tad bit more complicated than hydrogen is here. Not much, though, but it's the next simplest one on the periodic chart. And, of course, helium has 2 protons and 2 neutrons, sort of in a more complicated core, and a couple of electrons maybe orbiting around it, that kind of thing, to keep it neutral. So there's an electron there, and there's might be an electron there, sort of orbiting around, but that's it. And so you see then that the dust that formed the solar system wasn't particularly interesting dust. It was just made out of the simplest atoms, and in fact, it was mostly, to the tune of 75%, the simplest of all atoms, just some hydrogen floating around. That's it. So these really simple atoms here, as we'll see, are really the building blocks of things to come, sort of like Legos. Now, because Legos, you can get a really simple Lego and build more complicated things. Well, that's sort of the nature of the game here, that if you have maybe a bunch of protons and electrons in around and maybe a few neutrons around, then more complicated things can happen. But that really isn't a part of Astronomy 101. You'll have to go into Astronomy 102 and see how stars work before you see where the more complex elements came from. But that is just a little bit of a note there on sort of this issue here, that the dust we came from was very simple. Okay, now onwards a little bit to some more sophistication. So we agree then that without any big sophistication here, there was just this big ball, not even a ball, just a blob of dust sitting here. Okay, and we're going to hypothesize then probably that gravity maybe was doing a little bit of a job on here, pulling it in like this, because that's what gravity does. And again, why are we choosing inwards? Just what you might think. There might be a little blob of dust there that's getting attracted inwards to maybe some blob of dust there, but we wouldn't expect that this little piece of dust right here would be sort of being yanked out of the otherwise big dust ball that it's in. So that's about it. Okay. Next, the Nebular Hypothesis. Okay, fine. So we have some dust. What happened next? So that's the big question. What happened next to this dust? Because I'm still not seeing where planets or the sun could come from. But the next thing that we'll say, and this is honestly it, something happened. And that's sort of what happened next. Something happened. Okay. What would that something be? I have no idea. But what we think happened is that some sort of galactic event happened. And by galactic event, I'll say something like maybe there was a star that was sort of moving by. We don't expect things to be completely still. They were sort of moving by with some speed v. And as this star sort of moved by, maybe it exploded, who knows, or maybe it just moved by all on its own like that. This big star moved by, and of course, gravity, is always this thing that is out there. We had the law written down many, many videos ago. Something like Gm1m2 over d squared. So as long as we have two masses and some distance between them, there'll be a gravitational force. Well, we have this big dust ball here with a lot of masses in it, and we drew the purple arrows indicating some gravitational action going on there. But now when this star sort of passes, let's just maybe draw, here's a star, and maybe there's a distance to this part of the dust, there's a distance to that part of the dust, there's a distance to that part of the dust. And of course, this star here is moving in this direction. So what the star did, its gravity, let's just say, started to drag the dust a little bit here, started to drag the dust along. So what we sort of got then is that this whole bit of dust here that you see just sort of got dragged along in this direction. And I'm sort of, if you look at the little red dot, I'm sort of indicating this direction because that's sort of along the direction this star or whatever that something was happened a long time ago, is moving in. So it's here, and then it's here, and then it's here, and then it's here. And all along it's doing that, the force of gravity that is pulling on the dust is sort of following it along. These aren't light rays here. These are all these little d's, these distances here that go into the force of gravity here, just sort of drag the dust along, and then the star was gone. Again, or maybe it exploded or something like that. But in either case, the star isn't around. And no, I'm not saying that's the star that formed our sun at all. I'm just saying that's the something that happened. But this dragging motion is kind of interesting because what it sort of did, though, was sort of in part a force on the entire dust ball, if you will, sort of, that might have sort of been, in a direction like that, if you want. This is sort of the direction of the drag. Okay, I'm not speaking very certainly with any certainty here, but just something that could have happened. And so what are we left with then? Well, the star is gone. The dust is still there. And what happened then is here's our dust now. We don't have green dust. We have gray dust. Gray dust. Here's our gray dust. And when the star has passed, the dust is now spinning. And that is a huge issue now. We have a dust ball made out of this very simple atoms, nothing sophisticated about it at all, 75% hydrogen, the simplest atom there is, sitting there doing absolutely nothing, maybe a little gravity pulling it in. Suddenly, something zipped by or exploded that caused it to start spinning. And that spinning is a huge, huge, huge new bit of information that definitely is going to go into forming a solar system. The spin.